A very good afternoon, participants, and warm welcome to our sir, Parikshit Mahale, sir, Dr. Parikshit Mahale, sir. Now I would like to request Dr. Alauddin Ansari to introduce our speaker, Dr. Parikshit Mahale, sir.
Very good afternoon to all. Thank you, Dr. Ram Kumar, sir. It's my great honor and pleasure to introduce Dr. Parikshit Narendra Mahale, sir. He is presently working as a professor and head in the Department of Artificial Intelligence and Data Science at Vishwakarma Institute of Information Technology, Pune. He has a total 21 years of experience in the field of teaching and research. After having his PhD in the field of wireless communication from CMI Aalborg University, Denmark, he also worked there as a postdoc researcher. He obtained his MA degree in computer engineering from the University of Pune and BA degree from Amravati University, Amravati. He is the recipient of Best Faculty Award by Singhad Technical Education Society in association with Cognizant Technology Solution in the year 2009. His book, Data Analytics for Pandemic, a COVID-19 case study, was awarded as an outstanding book in STEM, that is Science, Technology, Engineering, and Mathematics category by CRC Press in the year 2020. He has been a reviewer of various conferences and journals on the globe. He has worked as a reviewer of many books for the publication like TMH, Pearson, Oxford Press, CRC Press, Stranger Nature, Elsevier, etc. He has authored 15 books in the field of computer science till date. He has total of 189 publications in various journals, conferences, and book chapters in his name. He also has 6 patents in his name till date. A very warm welcome to you, sir. Over to you. Thank you, sir. Please start the session, sir. Thank you. Thank you, sir.
Hello.
Sir.
Hello.
Yes, sir.
Yeah, what happened?
Hello.
Yes, yes, I can hear you. Can you hear me?
Yes, sir. It was not audible to you, sir.
Nothing was audible. Can we start now?
Yes, sir. One second, sir. A very good afternoon, sir. Now,
Good afternoon. Good afternoon.
I would like to request Dr. Alauddin Ansari, sir, to introduce our speaker, Dr. Parikshit Mahale. Dr. Ansari.
Very good afternoon to all. Thank you, Dr. Ram Kumar, sir. It's my great honor and pleasure to introduce Dr. Parikshit Narendra Mahale, sir. He is presently working as a professor and head in the Department of Artificial Intelligence and Data Science at Vishwakarma Institute of Information Technology, Pune. He has a total 21 years of experience in the field of teaching and research. After having his PhD in the field of wireless communication from CMI Aalborg University, Denmark, he also worked there as a postdoc researcher. He obtained his MA degree in computer science from the University of Pune and BE degree from Amravati University, Amravati. He is the recipient of Best Faculty Award by Singhar Technical Education Society in association with Cognizant Technology Solution in the year 2009. His book, Data Analytics for Pandemics, a COVID-19 case study, was awarded as an outstanding book in STEM, that is science, technology, engineering, and mathematics category by CRC Press in the year 2020. He has been a reviewer of various conferences and reputed journals on the globe. He has also worked as a reviewer of many books for the publication like TMH, Pearson, Oxford Press, CRC Press, Springer Nature, and Elsevier, etc. He has authored 15 books in the field of computer science till date. He has a total of 189 publications in various journals, conferences, and book chapters in his name. He also has 6 patents in his name till date. Sir, a very warm welcome to you, sir. Over to you. Thank you, sir. Please start the session, sir. Thank you, sir.
Yes, sir. Am I audible?
Yes, sir. Yes, sir. You are audible, sir.
Okay, thank you. Sir, you are going to be there in the session so that I can request you whether I am audible or not.
Yes, sir.
Right? Okay, thank you very much. So please confirm whether my slide is visible or not. My slide is visible, sir?
Yes, sir.
Okay. Fine. So, very good afternoon to all the participants. At the outset, I am very much thankful to Dr. Ram Kumar sir and his entire team for inviting me and giving me an opportunity to share my experiences on this very interesting topic of artificial intelligence and machine learning and its respective algorithms and implementation. Basically for next maybe 2 hours, my plan of action is going to be, first we'll talk about what is going on, what is the trend, and where this entire research in machine learning and deep learning is going and where it should go, what are the expectations from all the stakeholders when we talk about researching in this field. So you can look at the title of my presentation. It is AI, ML, DS, myths and realities. So in the first part, we'll try to talk about this part, and then in the second part, we'll move to the implementation of clustering algorithms, and then you'll understand what is required when you get into implementing some algorithm on machine. Is it fine? So I have a small request, rather small appeal to all the participants to please note down all the questions in your notebook or somewhere with all the questions which comes in your mind, and definitely at the end of the session I will answer your all the questions. And that's the reason why we all are here connected on this digital platform, so that there should be more takeaways, and you should also enjoy this teaching and learning process on this digital platform. And I would like to congratulate Dr. Ram Kumar sir and his entire team for organizing this FTP on this very interesting topic. So let us try to understand what is this basic terms. I know this is started yesterday. Yesterday was the first day, I think, and you all are having basic knowledge of this main buzzwords. But if I will ask you a very basic question that, thank you very much for nice introduction. I represent, you can see 2 logos on the first slide. I represent Vishwakarma Institute, at the same time also represent Savitribai Phule Pune University in various capacities. I am also associated with various board of studies across the globe, not only at national level, but also at international level, and fortunate to visit more than 17, 19 countries so far. So let's try to understand first. So that is what in the first part of my presentation, we talk about what is going in this field. Now, if you look at this word AI, you all will agree with me that this artificial intelligence is really not a new field. Even most of you, when you was doing your engineering, or including me, I also studied this subject, artificial intelligence. I hope you all are agree with me, and I will be happy if you can put your responses in the chat box, so that this entire session will be connected. Is it fine? So I hope this subject is covered by all of us. Then let us ask a very simple question to ourselves only, that what has happened suddenly in last 1 decade. This subject has again came into the focus. Even if you go beyond before 10 years, very few people knew about this field of deep learning and data science. Are you agree with me? At least say yes, at least say no. I'm waiting for your responses in the chat box. Are you agree with me that before 10
Yes, sir.
years these terms were really not aware? Is it fine? Okay, my request to all the participants to at least put your responses in the chat box. Thank you very much, so that this entire session will be interactive. So now what has happened in last 10 years, you all will agree with me that this sudden, there has been sudden change in this field, and this all terms like artificial intelligence, machine learning, deep learning, and data science has become emerging trends. So in my opinion, everyone should understand that why these trends have become emerging in this decade, and why they were not emerging before this 10 years or 20 years. Okay, so let us try to understand some factors responsible for it, and the first and most important factor is the availability of internet at cheaper and faster rate. Okay, what has happened? The internet has become very cheaper in terms of money, as well as it has also become faster, as you will all will agree with me. And due to that, what has happened? The number of users and number of devices connected to internet are increasing exponentially. And try to understand, every user and every device which is connected to internet is posting some data on the cloud. Is it fine? So that's how this the concept of cloud came in, because local storage was not adequate, and we require some remote storage on the internet to store this big data, and that is how this cloud and big data term came into picture. Okay, and due to this huge data which is posted on the cloud, and that is how this the provision is there, provision should be there to process this big data. And all that space is not the issue now, because memory is getting cheaper and cheaper day by day. And now every IT company, every IT leader, every IT solution provider is only revolving around data, and data is the main problem. I hope you all are agree with me, and that's the reason we are into this field of artificial intelligence and machine learning and deep learning and data science. Is it fine? So definitely this subject, artificial intelligence, is now that AICTE and UGC have started BTech program and master program in this field of artificial intelligence and data science. So definitely there is some vision, and yes, next 3 decades, let me tell you, there are going to be a lot of job opportunities in this field of AI and DS, and same equally, when there are job opportunities, there will be good market for engineering students for this branch, and equally that market will also drive us as a teacher. Is it fine? So let us talk about artificial intelligence, which was there in 90s, and let us try to talk about the same AI which is there today. Okay, so there is a big difference, and today this entire artificial intelligence is revolving around data mining. Okay, so it is basically a branch of computer science. And if I will ask you a very simple question, that can you tell me when this branch or this artificial intelligence term was coined, which was coined long back in 1956? Is it fine? So this is not new, but now this is again into force. This is driving the entire world only due to the huge amount of data which is surrounding to us. Is it fine? So please try to understand. And it is basic branch of computer science. Absolutely, you should have very clear about it. But the notion of this AI, which was there in 90 and which is there today, is completely changed. Is it fine? So definitely now what is happening in and around, you can see the next figure tells you about it. That you can look at this figure, and there is a lot of thought process behind this slide. And what this slide is talking about, this slide is talking about that everyone, every application, every use case surrounding to us is now supposed to be an intelligent application where you're all humans, those who are operating these use cases and applications will be replaced by a machine, and all these machines will behave like a human brain. Is it fine? Sir, am I audible? Yes or no?
Yes, sir. Yes, sir. Clearly audible, sir.
Thank you. Thank you very much. Okay. So try to understand what is requirement today, that every application, every use case which is or which was operated by human being should be operated by machine. Means machines are supposed to replace human being, and machines will behave like a human brain. Is it fine? So try to understand this is what is going on. But now, in my opinion, even I'm doing this in lot of many projects and books in this field since last 4 to 5 years, and I'm really enjoying, because sir has already mentioned I did my PhD in IoT, but since 2016 or 2015, late 2015, I have moved my complete focus into this field. And this is really emerging field. I will share some of the interesting case studies with you, which are already published by me and my team. So what is important point here I would like to mention is, before we get into this AI as a bigger picture, we should understand that in which situation do we require machines to learn. Definitely, first is an automation, because automation is something where machines will do all the jobs. But at the same time, there are some critical situations, critical applications where there is no any option than machine. Try to understand. Okay, so always AI application or application of AI goes to two types of application, where there is an alternative where human can do it or you can replace human by machine, and second category is where you have to replace human by machine. Is it fine? So let us try to understand what this is. So this is the next slide. When do we require learning, or when we want computers to learn? Are you getting? So these are some 4 points which everyone should understand, that when it's too difficult or too expensive to program them directly to perform a task. This is the first case. I will give you a simple example of the big huge data set is available to you, or and then you have to apply regression to this data set. So definitely, to apply the regression, linear regression from machine learning, and on the small data set of size 10 or 20 is very easy. I hope you all are agree with me. Yes, but at the same time, if you want to apply this same linear regression to the data set size of 1 lakh or 2 lakh, then definitely your existing traditional programming will not be sufficient. Yes or no? So this is the first case. Second case is human expertise does not exist. There are so many applications. I hope you remember the movie Uri, where that Garud was designed to take some picture from the terrorist area. I hope you remember, right? So why this Garud was designed, which was AI based Garud, which was pre-programmed, and it was sent to that terrorist area to take some picture, because our soldier human was not able to reach there. Are you getting? So our mission Mangal navigating on the Mars, where machine, humans cannot reach. So we need machines to reach there and do the task. Is it fine? Another application is where humans are unable to express their expertise, like speech recognition. And the most important application where we expect machine to learn is where our rule-based programming if then else, or depending on some rules which are predefined, your program will not be adequate because your solution changes in time. Is it fine? Like, routing on the computer network, and there are many situations like this in and around where, rule-based programming, pre-programmed model based on the some condition will not work, where we require context-aware decision making, context-aware, recommendations. So these are all some examples of artificial intelligence and machine learning. I hope the picture is clear. I hope I'm audible to you all and also visible to you all. Is it fine?
Yes, sir, audible.
Because very good. So I will keep you on troubling, sir. Sorry, because we are on the online platform, so we should be very much assured that we all are connected. Is it fine? Okay. Thank you very much. So when you look at these all applications of or any application of machine learning or deep learning, always the input is data. Okay, so now when you look into the fundamental aspect of this, and when you take any use case of artificial intelligence or machine learning, you will find that you are expecting humans to replace by machine. And when you want machine to behave like a human brain, then what is expected that your machines will perform one of these 6 operations, or maybe 2 or 3 of these 6 operations. Okay, so these are some major tasks which machine is supposed to perform, and these tasks are listed here. You want machines to decide, you want machines to learn, you want machines to predict, you want machines to recognize, analyze, remember. So these are some basic operations which you are expecting machines to perform when you are replacing machine, human brains by machine. Is it fine? So there is a lot of debate, try to understand. There is a lot of debate that if machines will start replacing human, then what about the employability of human? But don't worry, machines are only there to program, humans are only there to program machines. So there is no replacement for human. So one should take a note of this. Is it fine? Okay. So moving ahead, as if you have looked into the title of my presentation, the main point is that my point is look into this as a entire black box, and when this human brain is treated as a black box because it is to be replaced by a machine, and that's the reason this entire research in machine learning is misleading. Try to understand. Okay, because unfortunately the application of this artificial intelligence, machine learning and deep learning is taken as a black box today for the use case where we are applying. Okay, I will elaborate more on this. The main intention of this slide is very clear. Try to understand. We have this human, what is the ultimate objective of applying AI or ML or DI? To replace this human brain by a machine. But unfortunately, the entire research in this field only relying on giving some input at this end and expecting some output at this end, and the output is one of these 6 operations or few of these 6 tasks which are listed here. Okay, so when we look into it, try to understand, that is how the entire research is going on, and I hope you all will agree with me that all the even our MTech projects and research projects, all our students are doing what they generally do. They take some data set, even they don't study this data set clearly, even they don't have deeper insight of this data set, and they just pick up some existing algorithms on this data set, and they come up with some confusion matrix. Are you agree with me? Say yes, say no, say all of the above, say none of the above. What is your option? Are you agree with me? Yes or no? This is something is going in and around, and most of the research, rather I would say 80% of the research, is based on taking some data set from some repository, applying some machine learning algorithms on this based on the requirement, and then build that confusion matrix, and just to prove that this algorithm is better than this algorithm, and that's all. But try to understand, this is the basic part of this field. What is important is you study existing algorithms and then build something on the top of it. Is it clear? Understood? So when we say build something on the top of it, definitely what is first step is to take some existing, or rather the first step is to understand your data set very clearly, understand the complete aspect of the data set. And when we say complete aspect of the data set, you should have very clear idea about descriptive statistics of the underlying data set. Try to understand. So what do you mean by descriptive statistics? It is like, you should have very clear understanding about qualitative analysis of the data set which you are dealing. At the same time, you should have very good understanding of quantitative analysis of the data set which you are doing. Is it clear? At the same time, what is important is when you take some data set, please see that how this data set is distributed, and this is what something is missing nowadays. And I will share some of the examples with you in due course of time so that you will have very clear picture. So what is expected is what is happening inside a machine. Whenever you are applying some algorithm on the data set pertaining to the given problem, then what is my appeal, my request to you is first understand that algorithm mathematically on paper. Then see that how that algorithm will be implemented on machine with the help of existing advancement in the programming languages and platform. And then see that what can be done on the top of it. It is required, but basically it is missing somewhere. I hope you all are agree with me. So moving ahead, this field of artificial intelligence and data science is not now limited to an applications in information and communication and technology, but it has entered into many fields, starting from entertainment to agriculture to healthcare and many more. So these are some examples where this even now this artificial intelligence and machine learning has also entered into the this unfortunate situation which entire world is facing, that is pandemic study. I will also share some of the examples where we are working on the analysis of this pandemic data to come up with some recommendations, analysis of this COVID-19 data set, which is available at almost all the repositories of every nation. And then, how this field of artificial intelligence and machine learning is doing some important, operations, important tasks, and also doing a lot of recommendations to the all stakeholders. Okay, so this is something it's already we have discussed. This is really not a new branch which was coined long back in 1956, but now it is only, it is becoming more and more popular and entering into every aspect of our surrounding. All the use cases is only reason is data. Is it fine? So I am very sure that this figure is very, very much known to you, where everyone is saying that yes, AI is a bigger picture, and then we have machine learning is a subset of AI, and then again when we go into the next level, deep learning is again the subset of machine learning, where both deep learning and machine learning comes under a bigger picture of umbrella, bigger picture of artificial intelligence. So it is fine, yes, that is very true, but I want you to understand with the use cases. I want you to understand with some examples, so that the moment I give you some example, you should be very, immediately you should be able to answer that this is an example of AI, this is an example of only ML. Definitely it will be an example of ML, it will also be an example of AI. Try to understand. Is it fine? But I want you to come up with some concrete answers. So can anybody give me, I will go to the, this WebEx chat box, and can you give me an example of AI as a use case? Anyone? As a product, as an application? Anyone? Please put your answer in the chat box. Come on, first we have very short time. I would like to prepare a groundwork, and then maybe I will move to the implementation part. Come on. Anyone? You should be responsive, because that is why we all are here. We all are here to learn from each other. If I will ask you a very simple example, robot. So can you tell me robot is an example of only a machine learning, or it will go as an example of AI, or it will go as a only example of deep learning? Yes, anyone? Praveen Kumar, yes, very good. Praveen Kumar sir, then immersion, yes, very good, absolutely correct. So try to understand, this should be very clear. So now, if I will ask you the next question, that can you give me a specific example of machine learning? So definitely it will be also example of, you know, AI. But can you give me a specific use case with respect to only ML? Anyone? The specific example with respect to only machine learning. Yes, classification of medical images to diagnose disease, classification or optimization, absolutely correct. So this is what is expected. So when your problem deals with classification and clustering, try to understand, then that problem, brain tumor detection. Okay, so we will talk about it now. So detection is something different from classification and clustering. So try to understand the problem which deals with these two tasks of classification and clustering goes under the category of machine learning. Okay, then my immediate question would be, then Praveen Kumar sir, can you give me an example of deep learning now? Only one problem, one type of problem which can be solved by deep learning. Anyone? So try to understand, this is very important, that looking at the learning technique or giving an example to you, you should be able to answer that this is basically an example of, as a bigger picture, as an AI or only ML or only deep learning. So can you tell me what is deep learning then? Yes, okay, very good. So when there is a problem of, I will put my response in the chat box. So when there is a problem of identification and detection, that particular category of the problem goes into the deep learning. Is it clear? Try to understand. Understood? So this fundamental should be very clear. Now let me give you another. Yes, so it uses neural network, but I will not go much into it because that is really not the objective of today's session. But now let me ask you a very simple question. That is what is missing. Suppose I will ask you a very simple question, that can you tell me this Netflix? Do you know what is Netflix? Yes, Dharamvir sir, your answer is correct. So can you tell me Netflix? What is Netflix? Yes. My question to you is, yeah, TV series. Yes. So what category of application it is? Anyone? Please answer my question. Let your answer be wrong. No problem. So what is Netflix? Come on fast. Netflix is it is basically a recommender system. Okay, so I am expecting answer from you that it is a recommender system. Understood? All of you, are you agree with me? Yes or no? Yes. So when I talk about, when I say that Netflix is a recommender system, then again immediate answer question will be, then can you tell me, is it an example of machine learning or deep learning? Come on, please answer my question. ML. Very good. So it's an example of ML. Very good. So now again, when I come to ML, can you tell me, yes, Suhas Kulkarni sir, absolutely correct. But now when I come to ML, then can you tell me, will it go into the category of supervised or unsupervised? Try to understand, this type of study is supervised. Are you sure? Unsupervised. So try to see now. Some of you are saying supervised, some of you are saying unsupervised, but answer is one. Okay. So that's the reason the title of my presentation was Myths and Realities, and try to understand all my colleagues, all my friends, those who are senior to me, all my respected teachers, try to understand what type of studies required when you get into this field is looking at the algorithm and looking at the use case. You should be able to relate it with the type of learning and type of algorithm it is using. At the same time, Other way, looking at the data set, you should be able to answer this data set needs this kind of ML or DL algorithms depending on the type of problem you want to solve with available data set. Is it clear? So this is very much required, and that's the reason this entire research is basically misleading, but don't do that. Is it fine? So again, looking at this slide, this unit of big data will change every year. Even by 2025, zettabyte of data will not be big because data size is increasing day by day, and unfortunately, you all will agree with me. Please answer me in yes or no. That unfortunately, 80% of the research of machine learning and deep learning is being carried out on data set. Very few people, very few researchers are working on real-time data, which is the main characteristics of big data, that is velocity. Are you agree? Most of the research is being carried out on the data set which is available in the static form in the repository. Yes or no? Come on. I'm not getting any. I have received only one response for this question. But what is important is when you talk about big data, it should include all V's starting from volume, variety, and velocity as well, and then complexity and then size. So try to understand. So you should think about it. So moving ahead with the next point. So definitely this entire field of AI, ML, and DL require high-end machines with large storage, and definitely we are supported by a very good programming platform as well as programming support in terms of rich set of libraries. Okay, so this is what is AI. So my philosophy is always to from definition, not from the definition to use case, but I always drive all my discussion from use case to definition. So now I hope you understood what is basically AI. Okay, so you look at this now. Just automation is not an application of AI which can be done by the list programming which we used to do when this subject was there in our undergraduate. But now intelligent automation is basically an example of artificial intelligence where machine will take decision based on the situation. Is it clear? So rule-based programming, by writing a rule and then programming it, is really not a complete AI based application. This something which we call Alexa. So it's another most of the very popular use case which is very popular for almost all of the applications. So these are some examples. So now coming to the point, what is machine learning? Okay, I will not again go much into it because fundamentals, I'm assuming that fundamentals are already covered, but my perspective of machine learning, it is a subset of AI and which uses statistical methods to enable machines to improve on the performance. And already we have taken example of Netflix, and Netflix is an example of machine learning where again you should be able to answer whether it is supervised or unsupervised, because you could see that there are different perspectives with respect to the answer of this question. Is it clear? But we have to learn whether it is supervised, whether it is unsupervised. Okay, so I will really not go much into it, but these are some examples like where linear regression, you will see this more hands-on on again coming sessions where there is also hands-on on the classification algorithms. I have seen some your entire schedule. So try to understand. These are some very interesting examples. But again, when you take example of this linear regression, and if I will ask you that can you do something on the top of it, answer will be no. I know, because you have, what is required when you want to build something on the top of it. First, you have to understand how this linear regression works mathematically on paper, how it calculates mean square error, then how it minimizes that mean square error, and so on. Is it fine? So next point is try to understand when I say that machine learning also uses statistics, but you have to understand a clear-cut difference between machine learning and statistics, and I will give this example on this slide. So try to understand. I will just brief you with some example, and there even machine learning is using statistics. There is a clear-cut difference between statistics and machine learning. And what is that difference? In statistics, we formulate the problem statement and then we apply some statistical formula on this problem and then we generate the data set. Okay. Whereas in machine learning, we have data set. Okay. And then we apply some, we apply some questions on this data set to find some solution to the underlying problem. So try to understand there is a difference. So in statistics, we formulate the problem statement and then we apply some statistical formula on the initial values and then we generate some data set. Is it fine? That is how this linear regression and all, if you know how it works mathematically on paper. Whereas in machine learning, we have data set because every machine learning algorithm input is your data set and then we post some questions on this data set to find out the solution. Is it clear? So to make it more clear, in machine learning, data set is cheaper, whereas solution or the question or the answer to the questions are very expensive. Whereas in statistics, you can see that data set is expensive, whereas the questions we are that much are not that much important as it is there in the machine learning. So try to understand. Another point is, as you know that nowadays also talking about data science and this is something is now coming up. Even now I am into data science in last few years, where when I ask this question to anyone, then even you should be able to answer this question fundamentally. So it is something, the application of this AI, ML and DL for the business intelligence. Is it fine? So definitely data science also uses artificial intelligence, machine learning and deep learning along with some mathematical foundations, as well as some tools and emerging tools and techniques to deal with the data. But ultimately the objective is to apply this for the business intelligence. And when you use data science, when you work on the data science, always you deal with these three kinds of problems, that is descriptive, predictive and prescriptive. I'm very sure that you have heard about these problems, but I would like to share one of the very interesting book, which is let me know whether what I am browsing is visible to you all. So this was our, can you see what I am presenting to you all? Yes or no? What I am presenting to you is visible to you all? Can anybody put your response in the chat box?
Yes, sir. Yes, sir.
Yes, okay. So you can see here when this COVID unfortunate, uncertain situation was started in Indian context in March 2020. We started working on this book, which is more of applying these ML techniques and data science, data analytics techniques for pandemic. Yes, and this book, I'm also the author for this book, and I'm happy to share with you that this book has got 2 awards in a period of 1 year. This book has got outstanding book in science, technology, engineering, and management category. At the same time, this book also has got another award as a best book in focus series, concise book in this focus series of CRC Press, Tiller and Francis. So this is not a national award. This is international recognition which myself and my team has received in last entire 1 year. So this is what where we have applied both data. We applied both statistical theory as well as statistical analysis as well as machine learning analysis to analyze the data set which was available at that time. June 2020, we concluded this book and submitted to the press. But this book is doing very good across the globe, just to share with you. So the intention to share this with you is that you should have a very clear picture about this field of AI and data science is not it will be restricted to only one field. If I will show you another example, right? This is another our book which is recently published. So I hope it is visible to you. It is just recently published by Springer, and you can see what I'm browsing is visible. I hope so. Foundations of Data Science for Engineering Problem Solving. So this is a book. You can see I'm one of the author for this book, and this book was very well appreciated by the Springer Press, and this book is also doing very good. This is recent book which is published, and this was a project of almost 3 to 4 months, 4 to 5 months or rather, for all of us. But now this book is also doing very good, and I'm happy to share with you that there are lots of good comments we have received for this book. So another point is, yes, I can also show you what is that title, foundations. Healthcare. So this is our another, yes, foundations of, yes. So this is another book, Foundations of Data Science Based Healthcare IoT. So this is another book where we have tried to apply this data science to, this entire field of healthcare, rather medical IoT, how this data science will play a very important role in this field of healthcare IoT. So just to share with you that, this field of AI and machine learning has not limited to only one area, but it is basically now entered into all use cases, and you will see that now it is also entering rapidly in the preventive healthcare. It is also entering rapidly into agriculture applications and so on. So to explain it further, try to understand when you talk about this three types of examples or three types of problems, basically descriptive, predictive, and prescriptive. So we should understand very clearly that the underlying problem we are dealing with, it goes into which category. Try to understand whether it is a descriptive problem, whether it is a predictive problem, or whether it is a prescriptive problem. Is it fine? So let me give you a very simple example to make you understand. Let us take a data set of centuries. Hello, my slide is visible?
No, sir. Slide is not visible.
Yes, now?
Yes. Yes, sir. It's visible.
Yes. So, yeah. So I was on this slide. Right. Okay. I hope the slide is visible now, sir.
Yes, sir. Yes.
Okay. Fine. So, when you talk about, let us take a simple example of data set of the Virat Kohli, and data set consists of centuries scored by Virat Kohli maybe in last 1 decade. Now, from this existing data set, if you are interested to find out how many centuries are scored by Virat Kohli in particular period of time, with number of fours more than number of fours and number of six more than 5. So this category of the problem will go into descriptive analysis or descriptive problem. Try to understand. Okay. Now suppose on the same data set, if I want to find out how many centuries are likely to be scored by Virat Kohli in next 4 years, then this kind of analysis will be in the category of predictive analysis, because I'm predicting that how many centuries are likely to be scored by Virat Kohli in next uh, next maybe 5 years. Try to understand. So this analysis will go into the predictive analysis. Is it clear? Okay, now let us try to understand. Let us say that my descriptive analysis is saying that in maybe next 5 years Virat Kohli will score maybe 10 centuries, and this is the answer given by, or this is a prediction given by my predictive model or predictive analysis. Then definitely what is prescriptive analysis is what can be done so that Virat Kohli will score more than 10 centuries in next 5 years. Are you getting? I hope these three categories of the problem are clear to you. Yes or no? Yes. I'm not getting any responses in the chat box. So there are always three categories of the problem. Very good. Okay, so please, participants, please feel free to put your responses in the chat box. You know that when it is interactive, it would be more energetic for speaker also, that yes, speakers are connected and they are also responding for the all questions which are being posted. So please feel free to interact so that entire session will be very interactive and there should be more takeaways. Is it fine? So yes, so coming to the next point, this is what is the difference between statistics and machine learning. And let me go ahead. So next is deep learning. Already we have discussed when there is a problem of detection and identification, and the data set is very huge, then we think about shifting from machine learning to deep learning. But even most of the time, even when my student comes to me saying that, sir, I want to apply deep learning to this problem, and even my student is not able to justify that, do you really require deep learning? So first, please encourage, please request your student to justify whether you really want to go for deep learning or not. Okay, because we'll see it is again a particular kind of ML, as the Venn diagram indicates, and it is inspired by the functionality of our brain cells. We call it as neuron, which led to the concept of ANN, artificial neural network. Okay, so this is something all you know, but again, try to understand when we talk about this deep learning versus machine learning, there is a lot of discussion, there is a lot of debate, but we should understand very clearly what is the data dependency with respect to these two learning techniques, whether machine learning and deep learning. So my request to all of you to please look into this slide very carefully, and I will be happy if you can give here at least one or two observations. Yes, I will take a pause of 1 minute. Can you tell me what is your observation from this slide, please? Yes?
Yes, sir.
Yeah. Anyone would like to speak? Sir, do we have any provision for other participants to unmute and they can speak? Hello? Any participant would like to say at least single line?
Participants can raise their hands so that we can unmute them.
Okay, anybody can raise the hand and so that you can answer my question. Yes? Look at this figure very carefully. If we have more data, then deep learning model will work good. Yes. So try to understand. Absolutely, there is a response in the chat box. Let me see name of the participant. But I really appreciate your answer. Absolutely, Dr. V.V. Gomti, madam. Dr. V.V. Dr. V.V. Gomti. Okay. Okay. So yes. So this is what this figure is talking about. When you start growing with the data set, you will find that until some point your machine learning algorithms will outperform. Okay, they will give you continuously very good significant performance, but once after certain size of the data set, your machine learning algorithms will start performing, or they will start underperforming, means they will start performing constant. And this is a point will come where you will have to switch from ML technique to DI technique, that is deep learning technique. Is it clear? So this is very, very important, right? To understand deep learning is made for that with respect to the huge data set, but at the same time, it is more useful if you apply it for identification and detection problem where there is a multi-layer learning and you will get more accurate performance. Is it fine? Sir, am I audible? Fine? No response. Just imagine if this session would have been offline, it would have been more interesting, but at least I can see a response. I'm audible? Yes? Very good. Thank you. Thank you very much. Okay. So let's move ahead with a very small difference. So this is how this works. And let me give you some interesting. These are some live pictures from Europe where this deep learning is used for intelligent traffic management and so on. So let us quickly go to try to understand deep learning algorithms are to be implemented only on high performance computing like GPU and CUDA. I rejected 2, 3 theses and many papers where deep learning algorithms were implemented on the normal computing platform. It is not really expected. What is expected is these deep learning techniques and algorithms should be implemented only on high performance computing because they are made for that. Try to understand. Is it clear? So please take it on very serious note. So these are some. So this is one of the important slide which will tell you what is the difference between machine learning and deep learning actually in the real world perspective, and then maybe we will go to the implementation, the clustering part of our next session. Maybe in next 30-40 minutes we'll try to understand that. So ML takes decision on the past data, whereas it takes decision on ANN. Lower data for training is required in machine learning, where huge data for training is required in deep learning. Works on the low end system, whereas it creates high end system, high performance computing for the deep learning. And problem is divided in parts and solve them and combine, but problems is solved in end-to-end manner in deep learning. Testing takes longer time in machine learning. However, testing takes less time in deep learning. And you know that always more accurate result is there in deep learning. Is it fine? So these are some points which are really required, which are really to be noted when you cannot just take a deep learning as a concept to be implemented and go ahead. No, you have to first understand what is required. So these are some tools and techniques and concepts which are required if you really want to get into this field of AI, ML, and TL. Is it fine? So let us quickly now go through the second part where we will try to understand what how this clustering works on paper, and then maybe we'll also see the hands-on part of it. So now I don't know, my slide is not visible now. What I'm doing
Yes, sir.
is
Not visible, sir.
not visible. Okay, so just a minute. I will share. Is it visible now?
Yes, sir. Visible. Clearly visible, sir.
Okay, very good. Okay, so let us first try to understand the fundamental point here is, okay, let me make you understand how this clustering works. Okay, so I'm playing one video. I hope video is visible to you all. Yes.
Yes, sir. Yes, sir. Clearly visible, sir.
Okay, so I will not. I will, yes. Okay, so please see some examples which you know, which we all know, and then let us try to understand how it works. Okay, so I hope, am I audible?
Sir, you are audible, sir. Clearly audible, sir.
Okay, thank you very much. So let us talk about. So I already given you some insight on how this, unsupervised learning works. I will not go into the more details where data is unlabeled and you have to process that data for the purpose of clustering. Okay, so let's try to understand this on paper. So what is clustering or cluster analysis? And basically, there are many applications in the real world. Even you have seen now the recommender systems based on k nearest neighbor, which uses k mean, and there are many interesting applications of this clustering. And we also have used this clustering on our recent project, which is recently submitted to the Springer. And the title of our next book, which will maybe come in 1 month time, is Work-Life Balance During Pandemic: Mathematical Modeling and Machine Learning Analysis. Okay, where we have around 9 chapters, and we analyze the impact of COVID on employees in different sectors, where the sectors are education, IT, healthcare, agriculture, and real estate. And we have collected data, we have generated the data, we have analyzed this data, which was generated by the employees from different sector, and then we applied clustering there. And then this is going to be the very interesting book which is just recently submitted to the press. Okay, so there are many applications of this clustering, and let us try to understand one algorithm and how it works on Python. Basically, that will be the next plan for maybe next 20-25 minutes, and then maybe we'll open up the session for question answer. So try to understand before you apply the algorithm in the real world, you should be able to understand that algorithm mathematically on paper. Unless and until you do not understand it, it's of no use, because implementing any algorithm in Python by importing the libraries and writing 4 to 5 lines of code is really not a big deal. Is it clear? So please try to understand. Okay. So this is what is expected. There is a data set given which is not labeled maybe, and then you have to form the clusters of the similar items. Okay, so now this is the example we are going to take for our understanding mathematically how it works. And then so what is first step? So first step is take the input. Please understand very carefully. Then what is next step is select the value of k. So you can see here from the plot, it is very clear that yes, my data set will be into 2 logical clusters. So I'm selecting value of k as a 2, but the cross validation techniques is the right approach to decide value of k. But to demonstrate, I will explain it with a simple example of what we have taken. So initial 2 values, and when I'm selecting value of k as 2, so I'm taking first 2 rows for simplicity. Otherwise, you can take any first row, any 2 rows from the data set. Okay. So we selected 2 rows because we are considering the value of k as 2. Selecting first 2 rows just for easily understanding the problem. Otherwise, I have already made it clear considering any 2 rows. Okay. Now you have to find out the distance of these 2 rows from the centroid. So, and to find out the centroid, we have to use distance metrics, and there are 3 distance metrics which are available in the literature: Euclidean distance, Manhattan distance, and Minkowski distance. Is it fine? So these are the mathematical formulas for using the distance. So again, I request you to do some experimentation on the data set, apply all these 3 distance formula, and then see which distance will give you more accurate result. Is it fine? But for demonstration, we are using Euclidean distance. Okay, so what is next step? Step 3. So calculate the Euclidean distance of these 2 K1 and K2. So Euclidean distance from cluster 1. So cluster 1 is this, and cluster 2 is this. So definitely, this is what is, you can see here, cluster 1, so 185. So this is a distance formula. I hope it is clear. So 185 minus 185 plus 72 minus 72. So cluster distance from cluster 1 is 0, and distance from 185 minus 170. 185 minus 170, cluster 2. Okay, so it is 2193. So which is less? 0. So this will go to cluster 1. Okay, now 170 minus 185. And are you getting all of you? Yes or no? So 170 minus 170. So which is minimum here? Cluster 2. So this will go into cluster 2. Is it fine? Now what is next step? Next step is to take this row, third row. All of you getting what I'm saying? Yes or no? Yes? Yes. So now next step is to take 168 and 60. And already this is in cluster 1, this is in cluster 2. So find out Euclidean distance of third row from this cluster and from this cluster using the same formula. Is it fine? So what is this? Next is I'm taking next row and then finding a distance from cluster 1. I'm finding a distance from cluster 2. All of you getting yes or no? Yes. Okay. So now which is minimum? This cluster 1, distance from cluster 1 is minimum, or distance from cluster 2? Cluster 2. So it will go into cluster 2. Is it fine? So you can see the assignment, it will go into cluster 2. So like this, but now you can see here what has happened in cluster 2, there are 2 values. Because the third row also went to cluster 2. So you have to average the centroid. So now I average the centroids because always there will be 2 centroid because value of k we have selected is 2. Accordingly, if the value of k is 3, then for next row you have to calculate that next row distance, Euclidean distance from all 3 rows. All of you getting yes or no? Yes? Fine. Okay, so now I have averaged the cluster. So we have again 2 cluster K1 and K2. Now again apply the same step and take the 4th row, and 4th row is now 179.68. But 179.68 distance will be calculated from updated centroid. Is it clear? This is updated centroid. So this is the next step. So again it will go to cluster 1. So it will go to cluster 1. Means now in cluster 1 there are 2 values. So again you have to take the average. So this process will continue, and then ultimately you have this output, that assignment of the cluster. Is it fine? So this is what is important when you want to get into this field of machine learning, understand algorithms on paper, and then you have seen the application of this k-mean or KNN and many other algorithms which are there. So let's see now how this is basically outcome, and this is basically a simple algorithm. By taking the distance, I hope it is more clear to you all. So let us now try to understand how this is to be implemented. Let's say so what I'm doing is visible to you all, yes or no? So I'm starting the Anaconda navigator. It will take few seconds. I will just show you a simple program, how it works, so that because implementation is really not much difficult, and once you have clear understanding about algorithm, how it works in the background. Is it fine? Okay, I hope how it works on paper mathematically is clear to you all. Yes or no? So I'm launching the Jupyter notebook. What I am doing is visible to you all.
Sir, clearly visible.
Yes. Yes. Thank you. I will take it will take next 10 minutes to explain how it works, because that is what is understanding algorithm is very important, and then definitely implementation is also important. But fortunately we are supported by rich programming platform like Python and all these frameworks, which has really made our job easy, and we are really in a very comfortable advanced platform where implementing these algorithms is really not a big deal. Is it clear? Okay, so just few seconds it will start. Maybe meanwhile I can show you. Yeah, so this is some it has started. So this is a sample data set which we are discussing. This is a very sample. Yes. I hope this is what I'm browsing is visible to you all. Yes or no?
Yes, sir. Visible, sir. Very much
Yes.
visible.
Okay, so now I'm taking the sample data set. I also have 300 values, but you can see here the data set is unlabeled, where there are values of x1 and x2, and then I'm interested to find out, the clusters of it. Is it fine? So now this is something which, I hope 0.1 and 0.6 is the first value. Yes. Okay. So you can see this is a very simple program of Python where, I'm importing matplot.lib, then numpy, panda, then I'm reading this kmean.csv. This is a CSV file which we have opened, and similarly you can do it for any large data set. Don't worry. The same program will work properly for any data set of any size where you want to perform this clustering. So what is important is logical steps should be very clear. So I'm reading this in data frame df. So I'm reading x1 column into x1 and x2 column into x2, and then I'm printing this df. Okay, and then you can see so I'm here. So I'm here. So I'm printing this data set, what we have read, but now I'm printing it in Python. And then, just I'm plotting it with scatter plot. And you can see here, it will be into two logical clusters. And then, can you see here? I have imported sklearn library, sklearn.cluster. I have imported k-means. I have created object of k-means by providing number of cluster as 2. Yes or no? Can you see here? Bolo. Yes, no. Yes?
Sir, yes, sir.
Yes. Okay. So what happened? Okay. So okay. So I created here. You can see that I passed the number of clusters as 2. Okay, and then I'm plotting this data, but now I'm plotting it with the help of k-means. Is it clear? So when I'm plotting it with the help of k-means, you can see here I'm giving the ultimately what we are interested in. You must remember when you start deciding next row, finally you will get the centroids for cluster 1 and centroids for cluster 2. So every time these two centroids will keep on updating, so that it will decide that next row will go to cluster 1 or cluster 2, and depending on that the value of x1 and x2 will keep on changing. Yes or no? So you can see the final value of centroid for cluster 1. These are the final values of centroid for cluster 1, and these are the final values of centroid for cluster 2. Is it clear? Okay. Similarly, so this is just an example for you to understand how this k-means is to be done, and we have done similar cluster analysis for the data set which we have generated from the survey which we have carried out from different sources, through by preparing some questions and collecting the responses to these questions, and then we have formed this kind of clusters. Maybe I can show you one sample chapter from that so that you will understand how it works, and then maybe yes. So this is one example for you to so just for your understanding, you can see here, so data set, this is the education data which we have collected, and these are the statistical analysis of the data, and these are so this is already in place now, but just for example I'm sharing with you. So here we apply this, this is the example of clustering, how it has affected job profile with respect to the different parts, how it has affected the mental health, and so on. So ultimately, so this is a data set. I can also show you the data set for this. Mm, mm, mm. Yes, I can show you the data set for this. Is so this is the data set which is now you can see here the same data set. So I have just taken example of data set with 2 values, 2 columns, and 10 values, right? But same program will also work when the data set is used. So this is the data set. You can see we applied these clustering algorithms on this data set, which consists of around 350 plus records, and then we came up with some good inferences, to recommend in the book, and then finally how it works. Is it fine? So this is just I'm sharing with you just to make you understand and how this field is evolving and how you can apply it to any field based on the underlying problem statement. Okay, so I have another meeting in next 10-15 minutes, but before that maybe we can take up your questions if any, and then maybe we can conclude. I hope this is clear to you all. Thank you. Over to you. Over to sir. Any question? Hello. Hello. Am I audible? Yes or no?
Yes, sir. Audible, sir.
Yes, yes, yes. So I will open up the discussion for question and answer. Maybe for next 10-15 minutes, we can take your questions. I hope you enjoy what we have discussed is clear to you all. So what is expected is not just an application of algorithm on in Python or in its implementation. What is important is you should have very clear understanding about how that algorithm works on paper mathematically. Yes or no? Are you agree with me? Any question? Over to you, sir.
Please participate. If any participant would like to ask any question, please raise your hand. So we can
Please
unmute
ask
you.
question. Yeah, please
Sir.
ask the question. Yeah.
Yes.
Uh, uh, Hello, sir.
Yeah.
Am I?
Yes.
Sir, when you were going through the code, you have used k-means algo, right? So, sir, what if we don't have any clear line between two clusters, or our points or data we are having or data set we are working on have not a clear distortion or dispersion of data, that our two cluster or more than two cluster are having mixed point. So we can, what if we cannot draw a clear line or clear straight line? Then in that situation, what should
Yeah. So yeah, very good question. Very good question. So try to understand in K means always there will be two independent clusters formed. Whereas if new item is coming in and if it is lying somewhere, either in the first cluster or second cluster, then you have to apply K and N, K nearest neighbor. Is it fine?
Yes, sir.
Yes. Okay. So you have to apply K nearest neighbor algorithm in that situation for the problem which you are discussing. I hope your question is answered.
Yes, sir. Sir, one more doubt is there.
Yeah. Please.
So, when I was working on a data set downloaded from Kaggle, so I was falling in that situation where my accuracy rate was 1%. One means 100%.
100%.
So, how is this possible? That
It is. Yeah.
so maybe
It's really not
maybe
possible. Sometimes. Yeah.
what I thought is maybe data set what I am working on, maybe that is faulty enough that it is leading me to the 100% accuracy, because in real life this cannot happen, right?
Yes, yes, very good. So that is what the point is. There would have been a lot of discussion on this, but whenever data set is referred, you have to first work on the reliability testing. You have to work on whether the data set is reliable or not. And you apply some reliability testing on the data set, then you will understand that this data reliability testing, it gives you some score. I don't know how many of you heard about this tool Minitab. Okay, so you can use Minitab to perform reliability testing on the data set. Then only this situation will never come. Otherwise, if the data set is faulty, I'm agree with you and your guide. It can be there. Is it fine?
Yes, sir. Yes, sir.
Okay. Thank you. Any other
Thank you.
question?
Thank you so much, sir.
Okay, sir, the session was really interactive, sir. Also very
Thank you.
effective and informative.
Thank you. Thank you.
You have discussed various things, sir, about artificial intelligence, machine learning, and deep learning with live example like Netflix, robot. You have also discussed about cluster analysis, sir. All topic are very interesting. I am sure it will help to solve various research problem also. Thank you, sir. Once again, thank you,
Thank
sir.
you. Thank you. Take care. You can note down my email ID. I'm putting in the chat box. So this is my email ID. You can also note down my mobile number if it is required. It is 98224116. So feel free to be in touch. It is 9822416316. Those who want to be in touch, if you want to have some inputs on this field, always I will be there to help you. I will be there to guide you. Thank you, Ramkumar sir and entire team for invitation. Thank you very much. Take care.
Thank you, sir. Thank you, sir. Thank you all the participants. Thank you all the participants. Tomorrow we will meet at 9:15 a.m. Thank you all. All the participants fill up the attendance.